take up is a tie case. It is a tie. It is neither one nor minus one, but theoretically possible that is. But we are avoiding in this case as we restrict bipolar not to take up the zero into consideration. Now let's look at the what is our learning strategy. Okay, that is our interest now. The learning strategy means that is the weight updation, right? The learning strategy means what kind of weight updates you are considering to develop this one from the existing weights. That is, I think we have written something called delta wij above, if I remember correctly, for the weight update matrix or individual.
Yes, delta ij, sir, or hidden delta ij. For
Delta
the
wij, right?
yes, sir.
Yeah, fine. And the weight updates, yeah. Um, so that means like what could be the change in the weights? That is this one, right? Dou W that one, delta Wij. This one, yeah. Delta Wij is something very interesting here. To realize this one, you may need or you may take little time or work out different examples because it requires a lot of mathematics to understand, but I'm not touching that mathematics at the moment, but you will it can be sensibly understood from the examples at the very point of time. But if time permits and the question why, it may trigger you many times why this is happening, but before putting that one, I'm saying why you should uh, capture that logical idea that will come little later by intuition. So that is the learning technique is uh, something called the input. I'm putting it in red color so that you will understand the input xi times the output yi, the association. If it is something kind of xi is trying to associate it with yi, that means like correspondingly x bar is trying to associate with y bar, or if it is hetero association, we cannot say I with I, we can say J. So that I will write up J. In general, I'm not making I equal to J because if I equal to J, then we say that it is auto association. So that is a simple case. Auto association is just a sub case of hetero. Then once I and J are equal, that's mean. So once we have the simple technique of this one is a powerful tool of producting with input with the output, and there is something called a learning rate that we cannot ignore. That is a kind of what symbol we use, gamma or eta, which I almost all the time I switch it up. The learning rate earlier, I don't know, you check up, I don't go back and see. um,
It's
Learning rate
eta, sir.
eta, okay.
It,
Okay, I'll keep it eta same, so you don't worry about it. Eta times xi. So there is a this is actually, this is not for, this suggestion is not from the mathematics actually. Later it is proved very strongly. This is not from mathematics, it is from psychology. uh, Psychology, it is from the psychology. This principle psychologists used much way before mathematics, like during 19 if I remember correctly, during 1940s, exact year I don't know. um, Very long back, psychologists use this one to treat patients. This formulae, it later it is converted into mathematics, but it is in practice, it was in the psychology to understand neural behaviors, neurons, learning procedures, psychology, especially in the how humans are learning. How humans are learning. Uh, so it is a very powerful tool of learning technique of using this one. Now we coded and coded this one into simple mathematics formulae, but it is not a formula actually. It is a real thing in our brain. It is happening. Let's say, for example, you are reading a book. Uh, First time once you read a particular paragraph or a particular concept, you may not understand 100% perfectly. Then if you go for second time, your brain gets improves the whatever earlier existing information, and on top of it one, it frames a kind of another layer of it on top of it, and your learning procedure definitely upgrades it. Either you look at it, you don't look at it, but internally it upgrades at least as a particular delta epsilon, or a small quantity, whatever it is. It's different for different people. So that accumulates over a period of time, and so that association with learning, with the outcomes, strongly correlates between the concept which is exist outside and what after learning, and it is sitting in our brain. Just like the transformation of the learning mechanism, it translates the raw existing, because brains don't have the concept of taking raw things as it is, uh, just like capturing, unless it is through a learning procedure, and it remembers parallelly. We are not just learning as human brains, and they are every learning has an association with a memory. If there is no memory behind our learning, we can't say it is a learning, because if you read and you learn something, and if it is not memorized in some form, then there is no retrieval. There is nothing. It is comes up. So you learn a concept. Let's say concept is X, and you understood well, and your brain correlates the concept. Exactly the same concept is X, and this is the outside existing world, and it is in our brain, the concept. And this is a learning strategy, and it develops over a period of time. It is not just a single time. It strongly correlates. And if it is not just memorized, and the structure somehow, the learning paradigm, if it is not sitting in our brain, and next time you can't retrieve the learning what X with X. So this is how the memory, the word which we are using, the association memory, that is happening naturally in our brains, human brains especially. So this is the technique psychologists or neuropsychologists, they use it to and better understanding to how this learning strategy. They have come up with a lot of rules, and one of such, I'm not saying this is the only one. There are several parallels were there, but this is the very popular one, and they don't say it as a mathematical terms. If the psycho or neuropsychologists or psychologists, they say it is a kind of like uh, if you bond together, it fuse together. That means like if two neurons, if fuse together, that means you combine them, a neuron with another neuron, and that means like you trigger them, you fire them, you fire it means you are kind of like uh, uh, you are enforcing your brain to expand our neurons. That is what happens when you learn new things. That means like when you fire a neuron, and they fuse together. They fuse means when you fire it, they fuse it. That's called neuroscience. Scientists say this. That means like when your learning process is very strong and neurons gets fused together. So that's what we try to do with this structure, and that is what how the fusing of two neurons happens with this structure, with this one. But there is a lot of things. It is a natural observation from the psychologists how it is happening with how strongly it is happening. But we will see in mathematics, this one, like there are literatures you can study on this one. Uh, Mostly I forgot the actual name of the person or something. It's called Hepburn. Hepburn, due to I forgot his full name, last name, um, or maybe it's a first name. The Hepburn, due to psychologist Hepburn, it is developed. It's called, and the process is also called Hepburn learning. So these parameters all we whatever you are helps local update or helps local correction, these things. So this is due to psychologist Hebben. These are all comes from mathematics. Later it is proved and it works, and you can also prove it. It's not a great thing, and you need to first, before going into that intuition, you should develop why this is happening. That's what my goal now. Okay, let's see a few things. um, with this, suppose what we are writing, double delta wij is a kind of like a simple thing, just fuse together xj, sorry, xi yj, multiply them xi yj, not yj, so that it's a heterosociation. How do I write up in a matrix form? Like it's a individual. If I write up delta W, that must be gamma times um, x transpose y. I can write up, or I don't know what. That depends upon the column or row. But I write up x transpose y. It definitely indicates the matrix. Uh, Now, what do you think of this one? This is a matrix. Matrix comes from a kind of like x is n by 1 and y is 1 by m. So the matrix size is n by m, that delta w. But it should be m by n, so that I should change because it doesn't match with the size of w and this one. So maybe I will keep notation quite different, so that it would be y j transpose, or otherwise I will keep it as it is. This one m should come first, so that okay, y should go there. Y bar times x transpose. Yeah, now it works. This would be m by 1, this would be m by n. Yeah, now it's fine. So it is m by n matrix again. So that, so do you know this? What does it actually, the column vector times row vector? This is a, the matrix language. It gives a matrix. Two vectors gives a matrix. What actually physically represent this matrix? What it is saying about this matrix? Can you say anything from our linear algebra? If you multiply a column vector with a row vector, you get a matrix. Can you give meaning to it? I mean, what meaning you can give it? I'm just asking a meaning to it. The numbers, what they represent in this matrix. and the corresponding to this one, let's say y bar, it is x bar transpose. Your the meaning, anybody can give the meaning, please, because it is essential. By this time, you should know these concepts. Like it's not a concept; it's a mathematical understanding of what actually it is representing. If you don't know, I don't explain these things because this is part of our learning to substitute all these things.
Sir,
So
it's
yeah,
it's representing a sir area of one parallelogram, a rectangle, sir. Like area, sir. Like if y bar is a vector and x bar is a vector, sir. Multiplication is something area, sir.
no, it doesn't represent any area. These are all numbers and there is a matrix. And then how the meaning, you know the vector meaning, and you have another vector, and if you have the, let's, you can take up input or output vector from a transformation, but if you multiply two vectors, if you know the dot product, that is different one, you will get a one by one that you use many times. In other way, it's mostly called as outer product. There are two products, right, with the x and y. One is outer product and one is inner product, that is in this case dot product. That is not possible here, dot product with m by 1 with 1 by n. Usually that is possible with only both the vectors are same, where matrix multiplication comes like 1 by n times n by 1. So finally we'll get up with a single number. If you reverse them, you will get a full matrix. Okay, you try to understand that you are go back and see uh, the whatever resources or whatever linear algebra, you learn it back and look at them. And mostly I will take the meaning from the statistics. I will give a hint of like it is called, you have done the statistics course, you must have come up with that uh, correlation theory, where you have a correlation matrix there. Definitely, if you have two random variables x and y, and the covariance of x comma y is a matrix. Do you remember or no?
Yes, yes, a covariance matrix, sir. Diagonals represent the same, and
Yeah,
it is a symmetric matrix also, yes, sir.
yeah, of course. You can, you will get the same here.
Yes, then that's good. That meaning is covariance matrix.
It's not a covariance matrix. I don't say it's a variance term here. Really, I could say correlation, not the covariance. I can say they are correlated with x and y. Each one is correlated. Okay, so. mm So that is from the correlation, not from the covariance. Is a variance capture in the data. Usually that is x and y random variables in the two distributions. The how the variation is discussed, and correlation strongly determines about how they are related. Correlation. Okay, so this is uh, correlation matrix. But before the correlation matrix, you should understand how the meaning of raw mathematics says about the vector times vector in other way. Okay, that is actually other alternative way of saying this is a correlation from the statistical point of view. The this one a correlation of inputs and correlation. You can say this matrix is uh, correlation matrix. Okay, correlation matrix of I inputs and the outputs, that is the association x with y. I could say x bar with y bar. Okay, so these are all, you should not leave as it is, as granted. Okay, never in the mathematics. Only one thing you should do when you are learning a subject or concept: don't leave any question why how. You clear it off on your own, because you don't know at the moment. You write it up on the way the question arises in your mind. I write up many times why how these are all not just simple things. These things you should keep track of all these internal mechanics of mathematics. So these are all building blocks to understand further concepts. If you leave these why how concepts, questions, and the complexity increases as you learn. It obstructs you to learn new things. That's so at the moment you may not understand the why how. If somebody explains, you read once, but these questions you should keep always, hammer it as time goes on. Whenever you have free time, and just collect back and work it out and keep it aside, and again you take it back. So it is not a one time fixing. You can't fix all the why how questions in a single sitting. It's a journey to understand all the concepts, the internal things. So never leave any mathematical concept, not only just mathematics, anything which is questioned you, the question arises you, that should be the first thing. You should clear it off. But at the same time, the clearing, even I have a lot of questions which I arose my during my studies time. Still, a lot of pending questions are with me. That's 100%. I'm not sure of them. Very, very cornered and concrete questions. That still I work them the same. I what I do, I just say. That's what I'm saying. Like that is the only thing you built. Uh, a strong foundation which you can able to understand any concept. That is what, like, if you read something and you can translate that into in our own language, and you have a logical fabric in your brain, so that it consumes and it accepts whatever you study, whatever you read, whatever you listen, without having any filters. So that is only possible. uh, you should not leave any questions unturned. Okay. So uh, coming forward, this one. So now I write up a correlation matrix of this one W. What up here? Like, okay. Hmm. What correlation matrix? Now, if we send um, the input Excel, the Excel is the kind of like, I will write up here L equal to 1 to, let's say, um, L equal to 1 to what symbol I used here. M already have used it. I will use K. That means K such pairs if we take up, K such associations, like you have X bar, that is X1 with Y1, the vector X2 with Y2, and so on. I think the same K I have used earlier when I am describing association. I don't remember. The notations are quite tricky because we use, yeah, I think I have used K, it's not that same K. Oh, I didn't write anywhere the association. Right, this one, the K. Okay, use the same. X bar K goes to Y bar K. If you pass them this entire associations through the network with the W, that one. And what should be um, after several times, once one with X, you are pairing XL with YL for K such vectors. We are associating K such pairs. Then starting with the W matrix 0, that means like the weight matrix uh, initial weight matrix 0. Then we are keep updating delta W with the delta W. So that means like you will be having W equal to, now tell me what would be your first W if you start with the 0, and the 0 matrix is the first one, that is W plus delta W. So let's say this one is the first time you are doing it, let's say this one W1, I could say. Okay, what is the W1? W1 would
Sir,
be, yeah,
W plus or W minus, sir?
okay, doesn't matter, like you can keep it minus. It is not much important in the theory, as we don't much worry about, because sine function, it takes care automatically. If it is plus, sine function gets reverse, and if it is minus, the sine function gets plus. So it is a automatically weights adjust by plus or minus.
Okay, sir.
Okay, so yeah, now tell me what would be this W. I will keep
Sir, minus of x y bar eta gamma in, eta into y bar into x bar transpose, sir.
yeah, that
W1.
means like what you will get finally, and the W1 would
In
be,
W, sir, in matrix form, sir, minus eta common and then bahar outside of the matrix, and then we get, sir.
it is a m by n matrix.
Yes, sir,
That
M by
means, yeah, it is kind of like y. I write up in that, not in the transpose word. I write up like yi xi, um, the yi xi of that particular first one. Like if you supply the first vector, that means like this one, the first vector, then yi with xi, you will get a w1. That would be, w1 would be kind of like, I will write up this notation. This is also a matrix notation. This is m by n. You know that you write up matrix this way, right? Aij. You know this one. This is also one
yes,
notation.
yes, sir, yes, sir.
Yeah, the same notation I'm writing in the index. Yeah. So this is a w1. Uh, W2 is again the WI2 XI2 with the second association. This is a second correlation matrix. Okay. If you independently develop that one, if you just you are not updating with the earlier one now, what would be your W after two associations? What is your W? This is from the first association, that is the X1 is associated with Y1, I could say. This is a second association, that means correlation, this one. And now what is the W after two associations? Let's assume that if you have only two, then what is your W from this update? First initially 0, 0 plus W1, then then W1 plus W2. Your W would be W1 plus W2, right? You are updating. How are you updating? So for the k such updates, then it would be we have k such or k such things, so that you will be having uh, w equal to w1 plus w2 plus and so on wk. For every one you have a one such matrix, and for k associations you will be having this matrix. So k correlation matrix, you are summing it up through the weight updation principle, that you can think of this one. W is associated with the delta w. Okay. I will take up this one as positive, so that my gamma I have control with the negative signs. I don't want to use it, the negatives and the theory at least. So now what is it saying it is about? If you supply, now it's a surprise. You have a W now. If you supply any vector x from the k associations, okay, any vector x bar, which is equal to W times, sorry, it is equal to W1 plus W2 plus and so on WK times x bar. So now if we expand this one, this would be W if you take a particular one, let's say particular 1 2 3 and 7k, what index I can keep it, let's say p xp, pth vector. So w times x bar p plus, you can sum them up all the other cross products. So you're taking xp and we are expecting w sorry, this must be wp as well. Yeah, this is the direct association, and for all the L is running from 1 to k here. Uh, for all L not equal to p, this is W p times x bar. No, not W. Yeah, W not p. W with L. X bar with p. The p is the xp vector, so that we are picking up the pth composition outside, and the rest I am writing it up in a different separately. So now if you think of this one, these two products, it is the kind of like, cross product, cross terms, or cross talk, or cross things with L with P. XP is not directly things with it. It has some noise or some kind of a grab. It will bring it up. Now this is actually the abstraction. How much it is talking about this one. Usually this gets zero, especially if the inputs x1, if all the inputs xi's, this one xl's, are orthogonal to each other. This is a very straight from the orthogonal y. Again, that you think of it from this correlation point of view, will get that if the inputs are orthogonal, the matrix correlation, the corresponding L with P, the other ones get zero. Okay. Now we talk a lot of things here. Now thereafter we just did only one thing, that is x bar p. This one, the combination. Now we have to apply we have done the only linear combination with the weights with this one. That is what only one thing is happened, the weight with this one. Now we have to apply sine function. We haven't used that sine as of now. That sine thinks into the coming into the picture now. XPW, that final the outcome, the final outcome. What I'm saying, y, the corresponding y bar p equal to y bar p equal to, the sine of wx bar p. So this will happen. That means we are capturing as it is. You are asking x bar and you are capturing y bar after setting this w. That means like your patterns, all these associations are remembered inside this w. So your w is exactly picks w is exactly picks the whatever you ask for xp, and it will give the yp. Now that we will see in the examples, we will write up with some couple of examples, maybe in the next class we will see the examples how this is doing. Now the w is the one which is the kind of like memory. It's a kind of like acting as a memory. It is remembering all the patterns, and you ask for xp and it gives for yp. So how it is doing, the how powerful the correlation matrix, it is with the two things, or the two concepts you should digest on your own. That is, one is with this one, the fused one, eta xi yi, and another with the correlation matrix. Okay, these
Okay,
two
sir.
concepts you should come with the digestion. This correlation matrix is, I don't need to explain. This one is from the mathematics unit. This one you will realize through an example how it is possible. We will see that examples from maybe in the next class. I will keep it here so that I will remember. Yeah. Okay. We'll see maybe next class sometime.
Sir, if
Yeah.
you are free, you can take tomorrow also, sir. Afternoon time.
Tomorrow. Okay. I will let you know by today evening.
Okay, sir.
But you have some meetings, right? Usually.
So this Saturday there will be a freshers party, so there will be no club meetings on this
Okay.
Saturday.
Okay. Right.
That's
Then
why.
I will tell you. I will tell you by today evening.
Okay, okay,
Okay.
sir.
Thank you.
Okay. Thank you so
Okay.
much.
See you. Bye.